Have you ever wondered how ships, planes, and hikers determine their direction? Well, let's dive into the fascinating world of bearings in mathematics. Imagine an invisible line from one point to another. Bearings measure the direction of this line, typically as an angle. And here's the twist, it's measured clockwise from the north. It's like a compass rose on a map, where north is the starting point and you count the degrees clockwise. This simple but powerful concept is a cornerstone of navigation. Whether you're a ship sailing the seven seas, a plane jetting across the sky, or a hiker exploring the wilderness, bearings are your trusted guide. So, bearings help in determining position and plotting course. Interesting, isn't it? Now, how do you think we write or measure these bearings? Let's start with notation. Bearings are typically expressed in a three-figure notation. This means that if the angle is less than 100 degrees, we add a leading zero. For instance, a bearing of 50 degrees is written as 050 degree, and a bearing of 30 degrees is written as 030 degree. Now, to measure these bearings, you'll need a compass or protractor. A compass is a handy tool that points directly north. From there, you can measure the angle clockwise from north to your point of interest. It's like drawing an imaginary line from the north to your destination and calculating the angle of that line. On the other hand, a protractor can be used to measure the angle between the north direction and a line drawn to the point. Just position the flat side of your protractor facing north and measure the angle to your point of interest. So in essence, these simple tools, a compass and a protractor, become your guides, helping you to navigate through spaces. Whether you're on the open sea, hiking in the wilderness, or simply figuring out your direction, who knew that a compass and protractor could become such powerful tools in navigation? Now that we understand what bearings are and how to measure them, let's dive into some of their applications. You see, the beauty of bearings lies in their versatility. For instance, using trigonometry, bearings allow us to calculate the distance to a point. All we need is the bearing to the point and the angle between 2 points. Throw in the law of sines or the law of cosines and voila, distance calculated. But bearings don't stop there. They also help us determine the direction of celestial bodies like the sun or stars. Picture a sailor lost at sea, using the bearing of the North Star to find their latitude. Remarkable, isn't it? Moreover, bearings even describe the orientation of objects in space. Imagine pointing a telescope at a star with a bearing of 120 degrees. Fascinating, right? Bearings indeed are a versatile and essential tool in navigation and beyond. To sum up, bearings are angles measured from north, given in three-figure notation. They're measured using compasses or protractors and applied in navigation and object orientation. Next time you see a ship, a plane, or a hiker, remember bearings might be guiding their journey.